Can you hear me online? Am I audible? Can you hear me? Right. Good. Okay. So who introduced to us IPv4? Huh? ICANN. So how you are getting internet connectivity? Huh? Yes, guys. Can you hear me, guys? Am I audible? Right. So ICANN, the Internet Corporation for Assigned Names and Numbers. From ICANN, INA, it's going to receive the internet. Okay. INA full form, Internet Assigned Numbers Authority. Then INA to RIR, Regional Internet Registry. RIR to ISP. Okay. So ISP to small ISPs to our home. Okay. So large ISP in India, BSNL. From BSNL, Act people, Hathway people, they are going to get the internet. From Hathway, from Act, we are going to get the internet. Okay. So who introduced to us IP addresses and those all stuff? INA, you can say ICNN. ICNN, most of the people that doesn't know. INA, most of the people they know about INA. So people they are going to say INA, people they introduced to us IP addresses like that. Okay. Okay. So now let's see here. IPv4, right? So let's see, guys, here. Coming to IPv4. Coming to IPv4 32-bit addressing. Already we discussed, right? So coming to IPv4, it's a 32-bit. So we'll have more than 4 billion IP addresses in IPv4, right? So in IPv6, 128-bit. So we'll have 4 times compared to IPv4, 4 times more IP addresses we'll have in IPv6, right? So because of IPv6, still people that are using smart devices and those all stuff. But India like countries. So you can say ICNN, INA, whatever if you want to, you can say. The main so who introduced to us internet for us? INA, sorry, ICANN. From IC, most of the people that doesn't know ICANN. Generally, we are going to say INA. Most of the people that doesn't know ICANN. From ICANN to INA, they are going to get the internet. Okay. Shiva, got it. So clear, guys? Okay. So now, India like countries, not only India. So few countries still they are using IPv4. How? Few peoples still they are using IPv4. So not only India. So few countries still they are using IPv4. How, guys? Our Indian government they didn't provide the full-fledged permission to utilize the IPv6. So because of that reason, still we are using IPv4, right? So as of now we discuss. IPv4 range it got completed, right? IPv4 range it got completed. So if you doesn't have the IP addresses in IPv4, how Indian peoples they are trying to utilizing the IPv4 with the help of NAT concept. With the help of NAT concept, network address translator, right? So NAT concept. With the help of one public IP address, you can communicate 60,000 private IP addresses. That means with the help of one public IP address, we can able to communicate 60,000 hosts. 60,000 hosts. I hope you got it, guys, right? So because of that reason, India like countries still they are using IPv4. Now we are going to focus on IPv4, right? So maximum we are going to establish the network with the help of IPv4 only. So now we are going to focus on IPv4. So coming to IPv4, we have 32-bit addressing. So how many bits? 32 bits means 32 zeros and ones, right? 32 zeros and ones. 32 bits. So total 32 bit, it's a very huge combination. It's a very huge combination. Because of that reason, INA people, they got divided into 4 octets, right? 4 octets. So each octet having 8 bits. Got it, guys? Computer, mobile, everything is host only, devices only. Christopher, clear? So host means host, client, workstation, whatever if you want you can say, right? So how many bits will have? Total 32 bits will come, okay? So total 32 bits will have. So total 32 bit, it got divided into how many octets? 4 octets. Octet, guys, OCTET, octet. Okay? So 4 octets. So each octet having 8 bits. So this octet having 8 bits. This octet also having 8 bits. And this octet also having 8 bits. And this octet also having 8 bits. Total 8 bits. Each octet having how many combinations? 2 to the power of 8. That's it, no? 2 to the power of 8. So how we got a combination 2 to the power of 32? Because 32 bits will have. So now here we'll have only 8 bits. So can we write like this? 2 to the power of 8. 2 to the power of 8 means 256. So total 256 combinations will have 0 to 255. Can we write? 0 to 255 means 0 to 255 means 256 combinations. That's it, now. So this octet having 0 to 255, this octet having 0 to 255, and this octet also having 0 to 255, this octet having 0 to 255. So each octet, it got divided into decimal dot notation. Right, guys? Each octet, it got divided into decimal dot notation, right? So this is one dot, this is another dot, this is another dot. Because of that reason, our IP address, it is looking like this: 192.168.1.11. I hope you got it, guys, right? So guys, it's not exact value. For example, I have given each and every octet having one numerical value. So how you are going to get? With the help of binary calculation, or otherwise you can use binary calculator. With the help of binary calculator, we are going to get the numerical values. So I hope you got it. So this octet having how many combinations? 0 to 255 combinations. And this octet also having 0 to 255 combinations. This octet also having 0 to 255. This octet also having 0 to 255. Right? 0 to 255 also, it's a very huge combination, guys. 0 to 255 also, it's a very huge combination. So because of that reason, they introduced to us IP address classification, IP address classes. 0 to 255, they got divided into 5 classes. Class A, Class B, Class C, Class D, and Class E. So 0 to total 255 combinations will have in each octet. In each octet, we'll have the multiple classes here. Okay. So 0 to 255 is a very huge value. So because of that reason, INA people, they divide into multiple classes, 5 classes. Class A, 0 to 127. Class B, 128 to 191. Class C, 192 to 223. Class D, 224 to 239. Class E, 240 to 255. Right, guys? So let's see here. Now you need to get one doubt. Sir, class A, why 0 to 127? Why not 0 to 191? Why not 0 to 223? In which basis they got defined the like classification? Guys, please don't by heart the classes, class ranges. Don't by heart, okay? So class A, 0 to 127. So how we'll get the like class A 0 to 127 combination? With the help of priority bits. Right? Class A, Class B, Class C, it's reserved for LAN and WAN purpose. Who's going to manage LAN and WAN? Administrator. We only. Right? Class D for multicasting. Class E for research and development. So we are not going to use Class D and Class E. Class E for R&D purpose, research and development. You are going to, as an administrator, you are going to manage Class A, Class B, and Class C. Class A, Class B, Class C for LAN and WAN purpose. I hope you got it, guys. How they define the classification with the help of priority bit. 0 is a priority bit for class A. 10 is a priority bit for class B. 110 is a priority bit for class C. 1110 is a priority bit for class D. 1111 is a priority bit for class C. I hope you got it, guys. So, what is priority bit? What is priority bit, guys? A most significant bit of the first octet we are going to consider as a priority bit. What is priority bit? Most significant bit of the first octet we are going to consider as a priority bit. So how you are going to get the priority bits? With the help of binary calculation. Got it, guys? So IP address classification done by using priority bits. How you are going to get the priority bits? With the help of binary calculation. So what is priority bit? It's a most significant bit of the first octet we are going to consider as a priority bit. I hope you got it. So let's see, guys, how many people you know binary calculations? How many of you know binary calculations, guys? So let's see here. Who doesn't know? 2 to the power of 2 is equal to how much? 4. 2 to the power of 2 is equal to 4, right? So this is numerical calculation. So 2 to the power of 2 means 2 bits. That's it, na? So 2 to the power of 2 means 2 bits. 2 to the power of 8 means 8 bits. 2 to the power of 32 means 32 bits. So 2 to the power of 2, 2 bits. So can we write 0, 0, 2 bits combination? Can we write 0, 1, second combination? 1, 0, 1, 1. After 1, 1, can we be able to write the combinations now? No. Right, sir. Huh? ఇక్కడ రాయొచ్చా అంటున్నాను. ఇక్కడ దాకా కంప్లీట్ కదా దీనికి. 2 to the power of 2 is equal to 4. So how we need to write those combinations? 2 bits, right? Maximum 4 combinations we are going to get. 0 to 3. 0 to 3, 4 combinations. I hope you got it, guys. How we need to do the binary calculation. How many bits will have in each octet? 8 bits, right? Can we write 2 to the power of 8? Yes. No. Yes. 2 to the power of 8. So total how many combinations? 256 combinations. Can we write this numerical value into binary? Yes. 2 to the power of 8 mean 8 bits. 8 zeros is equal to 0. 7 zeros 1 is equal to 1. 6 zeros 1 0 is equal to 2. Like this, if you try to calculating in one place, so first bit it will become 0 and remaining all it will become ones. So this is the most significant bit of the first octet we are going to consider as a priority bit. So where it will become 0? In 127. So class A range 0 to 127. Priority bit is 0. I hope you got it, guys. So class A range 0 to 127. So how they define 0 to 127? With the help of priority bit. So what is priority bit? This is a priority bit. This is a most significant bit of the first octet we are going to consider as a priority bit. Got it? Now we are going to continue the calculation. So after 0, it will become 1, right? And everything it will become zeros again. That is 128. Then 129. Like this. After 120, 190, 191. Okay. 10. After 10, everything it will become ones. That is 191. Now class B range 128 to 191. What is the priority bit for class B? 10. Got it, guys? So again we are trying to continue the calculation. So like we'll get the 110 is a priority bit for class A. So like this, they define the IP address classification with the help of priority bits. Using binary calculation, we are going to get the priority bit. Okay. Priority. Mr. Hamid. So priority bit, okay? Most significant bit of the first octet we are going to consider as a priority bit, right? Okay. So I hope you're clear, guys. Most of the people they have some confusion. Most of the people they have some confusion in binary calculation. So we'll have one more calculation, but don't by heart the classes range, guys. So I'll teach you one more calculation for you peoples. Okay, how we need to get the proper range of IP addresses. That means classes we'll discuss now. Guys, what you need to do in a sense, we need to remember priority bits. It's a very easy, guys. It's not a big deal. Okay. 0 is a priority bit. 10 is a priority bit for class B. 110 is a priority bit for class C. So 110 is a priority bit for class D and 1111 is a priority bit for class C. I hope you got it. So those priority bits you need to remember. You need to remember. And next, how many octets will have? 4 octets will have, right? So each octet having how many bits? 8 bits, right? So each bit having one value, fixed value. Got it, guys? So how many priority bits? How many octets will have? 4 octets will have. Each octet having 8 bits. Each bit having one fixed value. So total how many bits? 8 bits, right? If you want, you can write zeros and ones. If you want, you can write zeros. If you want, you can write ones, whatever. If you want to get, so I have taken zeros here. So here total 8 bits will have in each octet, right, guys? Let's see here. So this bit value is 2 to the power of 0. This bit value is 2 to the power of 0. This bit value 2 to the power of 1. This bit value 2 to the power of 2. This bit value 2 to the power of 3. This bit value 2 to the power of 4. 2 to the power of 5. 2 to the power of 6. 2 to the power of 7. So those are fixed values, guys. Those all fixed values, right? Now we know priority bits, right? So what is a class A priority bit? What is class A priority bit? 0. 0 means 1 bit. 0 means 1 bit. So you need to calculate the first bit from your octet. So what is the like value? What is the value for this first octet? 2 to the power of 7. That's it, now. This octet value is 2 to the power of, this bit value, not octet value. So this bit value is 2 to the power of 7. So 2 to the power of 7 means 128, right? So class A priority bit is 0. 0 means 1 bit. So first bit value 2 to the power of 7. 1 bit, right? First bit value here. We are going to consider this is a first bit. 1 bit. 2 to the power of 7. 128. So we got a range, right? 0 to 127. We are writing from 0. Always we need to end with 127. We should do minus 1. 0 to 127. Total how many combinations? 128 combinations. We got a class A range 0 to 127. I hope you got it, guys. So next, class B priority bit 10, 2 bits. 1, 0, 2 bits, right? 1 is 1 bit, 0 is another bit, 2 bits. First bit plus second bit, 2 bits. First bit value how much? 2 to the power of 7. Second bit value how much? 2 to the power of 6. So 128 plus 64. 192, right? Then we end with 127 here. We need to start from 128 in class B. We need to end with 191, not 192, because we are writing from 0. I hope you got it. Class B range we got. It's very simple, guys. Next, class C. How many priority bits will have? 3 priority bits will have in class C. 110 is a priority bit for class C. First bit plus second bit plus third bit. 128 plus 64 plus 32. 224. So can we write like this? 192 to 223? Yes. We should not write 224 here because we are writing from 0. We should do -1 here. Clear? So class D, 1110, 1110, 4 bits. First bit plus, second bit plus, third bit plus, fourth bit. 128 plus 64 plus 32 plus 16. 240. Right? So now we need to start from 224. Then we need to end with 239. Because we are writing from 0. So last class E blindly you can write 240 to 255. So more than 255 it doesn't have. So I hope you got it, guys, online. So clear? Don't by heart, guys. Just you can explain like this to interviewer easily. He can able to understand. No need to by heart here. Okay. So don't by heart the classes, class ranges. Class A 0 to 127, class B 128 to 191, class C 192 to 223, like this. Don't by heart. So this is a logic behind. So based on this logic, they introduced to us IP address classification. Got it, guys? Good. Which purpose? Multicasting purpose. Viru. For doing multicasting and class C research and development. Right, guys. I got it now. Viru and Praveen Kumar. Let's see here. Class E, class D, we are not going to consider. Simple. Coming to Naresh IT. So in Naresh IT, we'll have 3 classrooms, right? 1 front office, right? 3 classrooms. 3 different classrooms will have, right? So classroom A, classroom B, classroom C. 3 classrooms will have. So if you remove the wall between those classrooms, what will happen? What will happen, guys, if you remove the wall between those classes? So we are unable to listen the sessions, right? Because maybe in classroom A, AWS, in classroom B, DevOps, in classroom C, Linux, like that. If they are trying to teaching, people, they are going to get confused if it doesn't have the partition in between, right? Those all classrooms, it having one compound wall. With the help of that compound wall, we are going to secure the classroom. Front office really does require walls, guys. Doesn't need, right? So class E, class D, you can say front office. You are not going to bother about class A, class B, class C classrooms. I hope you got it, Mr. Praveen Kumar and Viru. I'll tell you. Let it complete this. You can able to understand what is the use of class D and class C. Class D for multicasting, guys. We are not going to use class D IP addresses. So for multicasting purpose. Class C, research and development. Research and development purpose. Those both the classes IP addresses we are not going to use. So clear. So let's see, guys, here. Coming to, guys, we are administrator. We need to bother about class A, class B, class C. That's it. Don't think too much. No one they are going to ask about class D and class C. So clear? Right. So clear, guys. I hope you got it. Right. So now coming to class A, it got divided into network and host positions. Class A, class B, class C, everything it got divided into network and host positions. Okay. What is 8421, man? More than 255 it doesn't have. Blindly you can mention 255. Why again you are trying to calculating? I don't know really. So आप लोग खाना ऐसे नहीं खाओगे, right? ऐसा घुमा फिरा के खाओगे? हाँ? Mr. Praveen Kumar. So 242, 255 blindly you can write. Why again you are trying to 8, 4, 2, 1 like this? You need to mention there. More than 255 it doesn't have. Blindly you can mention there 255. That's it. 242, 255 is a class E. So we are not going to bother about class C and class C. Don't need to bother about that. No one they are going to ask about class D and class C. I said this is one type of front office. That's it. So research and development people they are going to use. We are not a research and development peoples. We are into very, very basic sessions. Got it? So let's see guys here. Class A, one network, three hosts. Network and host position. I know people they define class A, one network octet, three host octets. Class B, two network octets and two host octets. Class C, three network octets and one host octet. I hope you got it. So one network octet, three host octets, two network octets, two host octets, three network octets, one host octet. Okay, it's fixed. Simple. This is first floor. So this is second floor and this is third floor. Right guys? First floor people, they're unable to communicate with second floor people. Second floor people, they're unable to communicate with third floor people. Third floor people, they're unable to communicate with first floor and second floor peoples. Those all network positions. How many network octets will have? In class A, one network octet and three host positions, three host octets. So class B, two networks and two hosts. Right guys? Class C, three network and one host. Got it? So class C, three network and one host. So clear? Right. How we need to avoid the communication between those classes? How you are avoiding the communication between your classrooms? With the help of one compound wall, right? We need to do the partitions, right? So with the help of that compound wall, we are trying to avoiding the classrooms communication. Got it? So like the same way here also, we'll have one compound wall that is called subnet mask. What is that? Subnet mask. So class A subnet mask 255.0.0.0. Class B subnet mask 255.255.0.0. Class C subnet mask 255.255.255.0. Got it guys? So subnet mask, it will work like as a compound wall to avoid the communication between classes. Right? How you will get this subnet mask? How you are going to get the subnet mask? All the network octets it will becomes ones, all the host octets it will become 0. That is a default subnet mask per class. All the network bits, network octets, whatever if you want you can say. Okay, each octet having 8 bits, right? So all the network bits if it is become ones, all the host bits if it is become 0, that is a default subnet mask. So clear guys? So how many network octets will have in class A? So 1, how many bits? 8 bits, 8 ones, 8 zeros, 8 zeros, 8 zeros. Guys, if we having 8 ones, 8 ones value is 255. If you convert the 8 ones binary into numerical value is 255. If we having 8 ones blindly, you can write 255. That's it. 0 means always 0 only. So 255.0.0.0. All the network octets it will becomes ones, all host octets it will become zeros. That is a default subnet mask for class. So this is a default subnet mask for class A. 255.0.0.0. Right? So coming to class B, how many network octets will have? How many host octets will have? So 8 ones dot 8 ones dot 8 zeros dot 8 zeros. So 255.255.255.0.0. I hope you got it, guys. So this is a default subnet mask for class B. So clear? It's a default subnet mask for class B. So class C, 3 networks, 1 host. So 3 ones, right? 8 ones dot 8 ones dot 8 ones dot 8 zeros. 255.255.255.0. So I hope you're clear. So this is a subnet mask. In general cases, you can say it will work like as a one compound wall to avoid the communication between classes. Without providing the subnet mask, you are unable to establish the network, remember. Okay. Without, in Windows automatically it will take, but in Linux we need to provide manually. In Windows, if you try to providing the class A IP address, automatically it will take subnet mask 255.0.0.0. But in Linux, we need to provide manually. Got it, guys? So next. So class A. So let's see, guys, here. Class A 10.0.0.02, 10.255.255.255. Class B 172.16.0.02, 172.31.255.255. Class C 192.160.0.02, 192.160.255.255. What is this? Private IP address range. We have two types of IP addresses, private and public. So this is private for intranet, for intranet, public for internet, public for internet. How you are going to get the public IP address? How you are going to get the public IP address, guys? ISB. Yes, ISB only they are going to provide the public IP address. How you need to know the public IP address? Open web browser, Google, then what is my IP? Got it? So open web browser, and then search in Google what is my IP. Then it will provide the an IP address that is called public IP address. How to get the private internal IP address? Ifconfig IPADDR command in Linux. Coming to Windows, ipconfig/all, ipconfig, those commands you can use. Internal, external, two different IP addresses will have. I hope like you're doing AWS. How many people you have completed EC2? Apart from my batch. How many people you have completed EC2, guys? So if you're launching the EC2 instance, how many IP addresses we are going to get the EC2? What kind of IP addresses will have? Public IP address and private IP address. So why we need to use public IP address? Why two IP addresses, guys? One is enough, right? Why they are providing two IP addresses in AWS EC2? Yes. To access the EC2 instance remotely from North Virginia and California without internet, it's possible. Which IP address you are going to use to access the remote machine into your machine? Using RDP, using SSH. Public. Public for internet. Private for intranet. Did you completed VPCs? VPCs. So, how many types of subnets will have? Subnets only we are discussing now. How many types of subnets will have? Public, private, VPN, related subnet. 3 types of subnets will have, right? So public subnet having the public IP address, it is going to allow to access the missions through internet. Private subnet instance can be able to access through internet. Why? Why, guys? Because we doesn't have the public IP address, right? If you doesn't have the public IP address, how you are going to access the EC2 instance? Through PuTTY, through RDP. Right. Latif, 3 types of subnets will have, you can check. Okay. Right, guys. So clear. I hope you got it. So if you having any doubts, any questions as of now, VPN only subnet, right? VPN only subnet. Very good. Okay. So we'll have few calculations here. Can we continue? It will take more than 15 minutes. Yes, online. Yes, guys. Can we? Right. So we'll finish today this and tomorrow we'll do subnetting. Okay. Very good. So each and every class, in each and every class, how many networks we can able to establish, how many hosts we can able to connect into each network, now we are going to know with the help of those calculations. As an administrator, you need to establish the network. In the sense, we should understand which class is a preferable. With the help of this calculation, easily you can able to understand which class is a preferable for us. Always class C is a preferable network, right? If someone they're asking to you which class IP addresses are preferable for to establish the network, always class C is a preferable class. Class C, right? Why class C? We are going to discuss now. With the help of few calculations, how many hosts we can able to connect into each network, how many networks we can able to establish with the help of class A. Now we'll discuss. Got it, guys? So this is a formula, guys, for knowing the networks. 2 to the power of n minus p actually formula. In class A, we need to add minus 2. Minus 2 only in class A, not into class B and not into class C. So actual formula is 2 to the power of n minus p to know the networks. How many networks we can able to establish with the help of class A. 2 to the power of n minus p minus 2 we need to provide here in class A. I'll tell you what is minus 2 and those also no need to bother, right? So now how many network octets will have in class A? Octet 1. So each octet having how many bits? 8 bits. So how many host octets? 3. 3 8 are 24. So priority bit 0. So priority bit is a 0. So can we consider 0 as a 1 bit? So 0 means 1 bit only. So those all we need to substitute into formula those values, right? So network formula, how many networks will have we need to know. 2 to the power of n minus p. 2 to the power of n minus p minus 2 only for class A, not for class B, not for class C, right? Why minus 2? 0.0.0.0, this is unknown network. We are not going to use this 0.0.0.0 network in our environment. So 127.0.0.0, this is loopback network. Unknown network and loopback network we are not going to consider to establish the networks, right? So 0, 127, both we are not going to consider, right? So because of that reason, minus 2 here. So unknown network means 000 network, no one they are going to use. What is the use of loopback network? So this is loopback IP address, guys. 127.0.0.1 is a loopback IP address. So what is the use of loopback IP address? To check the outgoing traffic. Simply you can say your NIC card, it's working properly or not, we can check. So how to check? Open terminal, execute this command. Ping space 127.0.0.1. And if you're getting the reply from this IP address, that means your NIC card, it's working properly. We can able to send the data and we can able to receive the data. I hope you got it, guys. Yes, no, clear? So because of that reason, we are doing here -2. So we need to do -2, right? So we need to substitute the values into this formula. 2 to the power of n means n value 8 minus 1, priority value 1, priority value 1, minus 2, 2 to the power of 7 minus 2, 128 minus 2, 126. 126 networks we can able to establish with the help of class A. So let's see, guys, here. 2 to the power of n minus p minus 2. This is a formula. If you substitute the values into this formula, 126 networks we can able to establish. Got it, guys? Now, in each network, how many hosts we can able to connect? Yesterday, with the help of switch, we established one network, right? In that network, how many hosts will have? 4 hosts will have, right? Like the same way, in each and every network, how many hosts we can able to connect? With the help of class A. So how many networks we can able to establish using class A? 126 networks we can able to establish using class A. Then host formula. 2 to the power of h minus 2. 2 to the power of h minus 2. So minus 2, one is network ID, another one is broadcast ID. So let's see, guys, here. For example, so this is class A private network, right? So network ID, all the host bits, it should become 0. That is network ID to identify the network, right? All the host bits, if it is become ones, that is broadcast ID for doing the broadcasting into the network. In between 1 to 255, those all valid IP addresses we are going to assign for missions. Only 10.0.0.1, 10.0.0.2, 3, 4, 5, like this till 255 IP addresses will have. Only those IP addresses we are going to assign for hosts. We are going to assign for devices in network. So clear, guys? Network ID we are not going to use, and broadcast ID we are not going to use for missions. Each and every network, it having one network ID, one broadcast ID, guys. So network ID to identify the network. So how you are going to identify the network ID? Network ID, all the host bits, it should become 0. How you are going to identify the broadcast ID? All the host bits, it should become ones. That is broadcast ID. What is broadcasting? Yes, guys. What is broadcasting? So let's see here. I hope you're clear what is NID and what is BID. Network ID and broadcast ID in between will have valid IP addresses. Okay. So we need not to allow the network ID. We need not assign the network ID and broadcast ID formations. So because of that reason, we need to provide -2 here. So we are avoiding network ID and broadcast ID and substitute the values into this formula. 2 to the power of 24, right? Host value 24 -2. How many hosts we can able to connect into each network? Got it, guys? Host by network. those many hosts we can able to connect into each network. More than 1 billion, right? Yes, no. Like the same way for class B. So usually no one they are going to use directly class A, guys. If you're having the more hosts, then only they are going to prefer. So maximum people they are going to prefer small networks. So who's going to connect more than 200 missions into each network? If you try to connecting more than 200, 300, 500 missions, broadcasting it will happen. If you're having the more broadcasting, so network data transportation, it is going to become slow. Got it? Right. So coming to class B. So how many network octets will have? 2. 2 means 16. 8 plus 8. Then how many host octets? 2. 8 plus 8. 16. Then priority bits. 1, 0. 2 bits. Same formula, but you should not use -2 here because we doesn't have 0, 128 here. It will start from 128, right? So it will start from 128. No need to provide -2 here, right? So 2 to the power of 16 minus 2, 2 to the power of 14. So n means n value 16 minus 2, priority bit 2, 2 to the power of 14. How many networks we can able to establish? 16,384 networks we can able to establish using class B. And how many hosts we can able to connect into each network? 2 to the power of h minus 2 network ID and broadcast ID. I said na, each and every network it having one network ID and broadcast ID. So 2 to the power of 16 minus 2. Host value also 16, right? Because two hosts will have 2 host octets, 2 host octets having 16 bits. How many networks we can, how many hosts we can able to connect into each network? 65,534 hosts we can able to connect into each network. So I hope you got it. 127.0.0.1 is a loop back. So we are going to use this IP address to check the outgoing traffic. Shiva, ping is a command to check the outgoing traffic. Using the ping command, we are going to check this command you need to use. Ping space 127.0.0.1. Simple, guys. Your NIC card, whether it is working properly or not, we need to check. In the sense, we should use this command. If you're getting the reply from this IP address, that means your NIC card it's working properly. If it is not getting the reply from this IP address, that means you'll have some problem with your NIC card. Right? Okay. So now class C. Why class C is preferable, guys? How many network octets will have in class C? 24. 380. So how many hosts? 8. Priority bits? 3. 110 is a priority bit, right? 2 to the power of n minus p. 2 to the power of 24 minus 3. So how many networks? Because of that reason, it's a preferable class to establish the network. These many networks we can able to establish. And how many hosts we can able to connect into each network? Maximum 254. 2 to the power of h minus 2. 2 to the power of 8 minus 2. So 254 hosts we can able to connect into each network. If you need to connect more than 254 hosts, then which class? Class C. If you need to connect more than 500 hosts, then you can use class A. So I hope you got it, guys. This is all about IPv4. Tomorrow, subnetting will do. Tomorrow, subnetting concept will do. How to divide one network into multiple networks. Like while we are doing VPC at the time, we are dividing like multiple subnets, right? Private subnet, public subnet, right? So I hope you're clear, guys. If you're having any doubts, any questions, please. Yeah, welcome. Bye, Nagreddy. So IPv6 we are not going to discuss here. Viru. And 90% people they are teaching IPv4 only, right? IPv4 in AWS also. They're going to use IPv4 only. Who's going to use like IPv6 and those all? Okay. So this is a basic Linux. We are not going to cover IPv6 here. It's not a big deal. It's a very easy. It's to understand. So got it, guys? Little information. Little information, not now. After completing the session. Okay. So let it complete our syllabus. Then we'll discuss about IPv6. Okay. So got it, guys? Yes, no.